Alright, so here we are with angles formed by parallel lines and transversals. It's our Chapter 3, Section 2 notes. Our objectives are going to identify parallel and perpendicular and skew lines. So we're going to start out with some of that identification. And then we're going to end up with identifying pairs of angles that are formed by two lines and a transversal. So we'll kind of go over what all of that means. So in our second slide here, we do have each of these defined. So kind of talked about it a bit already, but parallel lines, notice this symbol here, that's actually used to say that two lines are parallel. So even if you look at it here, you see line AB is parallel to EF, so that we don't have to write parallel every time. You'll also see here we're seeing that EG, the line, is parallel to FH, the line. So let's see, where's FH here and EG here. So the front of this box here. So that's your parallel lines. They're coplanar, meaning they'd be on the same plane. So looking at the example we just did, EG and HF are on that front of the box, which is a plane. Then we have perpendicular lines. I did mention this in the previous homework assignment, but this upside down T tells you that things are perpendicular. So for instance, this here is red. Line AB is perpendicular to line AE. So where's that? AE and AB, you'll even notice that there's that little box there that would indicate that it's perpendicular, or 90 degrees. Then we have some new ones, so skew lines. Okay, so skew lines are not coplanar, so not on the same surface, and they are not parallel, and they do not intersect. So, let's see. EG, for instance, and BW could in fact be parallel. So if I drew kind of the surface that goes through EB and GW, this green surface would in fact have both of those lines on it. So we can't say that EG and BW are skew, okay, because they could be on that same plane. However, if I instead used, let's erase this, EG and BF, notice that if I actually drew the lines, of course they'd go together because we're talking about 3 dimensions on 2, so that's not really what I'm looking at. But thinking of just a box and making a line that's on that front corner and then one of the top right corners, these lines are not on the same plane, and they're definitely not going to ever intersect if you were to go on for infinity. Their example is AB and EG, that's fine as well. So AB, again, on the two-dimensional surface will meet, but that back side of the box and then that front left are never going to meet if you extended them forever. So those are skew lines. They're not parallel and they're not coplanar. So it's an interesting way of looking at it. Alright. Three-dimensional parallel lines are skew lines, but anyway. Then we have parallel planes, and so looking at this box, the top of the box and the bottom of the box, unless it's a weird box, are going to be parallel, meaning the same distance between any point on them. The left and the right sides are going to be parallel, and then also the front side and the back side are also parallel planes. And so notice the way you would write it is just the way you would write it with a line. You'd write plane ABE, so in that case the top plane is parallel to plane CDG, which is the bottom. C. Where's the D? Oh, I believe that's supposed to be the D. That's weird. It's all of a sudden a W. Okay, moving on. So that's your D. So CDG is the bottom one, and ABE is the top one. So those two are parallel planes. Super. Alright, so we're going to go ahead and identify each of the following in this example. So we want a pair of parallel segments. There are of course tons of parallel segments here, but the idea is to, first of all, remember how to draw or write a segment. So for instance, CD needs a segment picture above it. And then parallel to that is going to be this front one then, BE. And of course we're going to say parallel. That was a really bad parallel. And then BE. So that's segments are parallel. Then we want a pair of skew segments, same as skew lines. So let's see, I've got this one in back, which I'll call DH. And that one is skew, so we're just going to write and. BE, that front one there. And of course there are lots of options for these. Then we have a pair of perpendicular segments, so that means they're going to meet at 90 degrees. I tend to not risk it, and I just go for actually where the 90-degree symbol is, so here. So I'm going to say BF, the segment, is perpendicular, the symbol, to FJ, the segment. And then they want some parallel planes. So let's try the top plane, which I'm going to call plane BCD, and then the parallel symbol, and then plane GHJ. There you go. Alright, then we have vertical angles theorem, so just a reflection back on that. Remember that vertical angles are the ones that are across from each other at an X. They're going to come up with the new set of angles that we're talking about today. And other than vertical angles, we also have vertical angles that are more or less horizontal, okay? So the ones that are across from each other at that X, but in the left and right idea, those are also going to be the same measure, turns out. Alright. So looking at our new types of angles, basically what's going to happen is we are going to have something called a transversal. And a transversal is a very special line. It intersects two coplanar lines at two different points. Okay, lots of fun. So basically, taking a look at the transversal is this line right here. It's the one that goes through two lines. So here's your two lines at two different points. Alright, we can't go through two lines at the same point, so that's not going to happen. Alright. So, if that is our transversal, then we've got some types of angles here. So we have something called corresponding angles. Alright, and corresponding angles lie on the same side of the transversal, on the same side of lines R and S. So line R is up at the top, line S is down here. And so when I think of corresponding, I think of this as like, okay, it's a weird example, but we're going to do middle school tables. Okay, lunch tables. So let's imagine that you've got these circular lunch tables, okay? And if you remember back to middle school, or maybe you're still in middle school, hey, what happens is you don't want to let everyone know that you like this certain person, but you've really got so much in common that you end up sitting at the same spot, but just at a different table. Because again, you're together, but you're just like not together. Okay, so in that case, notice that angle 3, for instance, is sitting at that southern left part of the table. Well, angle 7 is also sitting at that same spot, but just at a different table. Okay, and so those are corresponding angles. The ones that they give are 1 and 5, so up here and up here. Again, at the top left, and then the other table, top left. Okay, so that's the example I like to give, but you know, to each his own. So that's my corresponding angles. Alright, then we have alternate interior angles. And this is where, especially if you look at these colors here, between the two lines that we're talking about is interior. And then, of course, outside of the two lines is your exterior. So if we want alternate interior, that means alternating sides of the transversal. So one over here and one over here. So that's the alternate part. And then interior means that they're going to be inside. So alternate interior, in this case they give you 3 and 6. Okay, But we're not going to do 5 and 6 because actually 5 and 6 are what we've already mentioned as a linear pair in a separate lesson. So linear pairs are also options. We also have vertical pairs like 6 and 7, but again, not part of our new angles at least. So, taking a look at what we have, alternate interior, whoops, drew my line kind of funky, is 3 and 6, but also angle 4 and 5. Okay. Corresponding angles, there are actually 4 of them, so go ahead and get all total of those. Alternate exterior angles, so that's going to be, again, alternate of the left or right of the transversal, and then also either on the top or the bottom. So, for instance, they give the example of 1 and 8, but there's another set of 2 and 7. And then the last ones are same side interior. So again, going back to that orange part there, they're on the same side and on the interior. So same side of the transversal, and so we're actually looking at 3 and 5 in that one. The other set is 4 and 6, which are also same side interior. Alright, so those are all the names. Again, the only fun one that I had was for corresponding angles. But again, alternate interior, it's all given. Alternate side of the transversal inside of the 2 lines across. Alternate exterior, alternate side of the transversal in that exterior part, in that blue part. And then same side interior, again, same side of the transversal on the interior of the angles that we're talking about. Alright, so that's a lot of names, and we're going to use them quite a bit. So taking a look at what we have here. Again, this picture doesn't exactly look like what we had, so we're just going to go ahead and make it look like that. So if we're looking at angle 1 and angle 3, let's see, angle 1 is here and angle 3 is here. They both touch this line here, and so that is going to be my transversal. Okay, the angle that they both touch is the transversal. And then the other 2 lines are the ones that you're either going to be on the interior of or the exterior. Okay. So if we're looking at 1 and 3, okay, taking a look, sometimes it helps if you rotate the picture. This is at the bottom left of this intersection, and this one is also at the bottom left of that intersection. So going back to our names, those are corresponding angles. Alright, then we're going to start all over again and identify the 2 angles we're looking at. So in part B, we're looking at angle 2 and 6. 2 and 6 both touch this line. So that's going to be our transversal. And then the other 2 lines that make it up, alright, this is going to be your interior. Out here is your exterior. And so notice that both of these are on the interior, and then we just need to identify, are they on the same side of the transversal? Nope. Are they on opposite sides or alternate sides? Yes. So in that case, we're going to go with alternate interior angles. Okay. And then our last one, again, identify which 2 angles we're talking about. So 4 and 6. Which line do they both touch? That's this one. So that's our transversal. And then kind of start to identify where the interior and the exterior is. So here's interior, so clearly they're not inside of there, but they are on the exterior. They're outside of that yellow part. They are also on alternate sides of that transversal, so that means that we are looking for alternate exterior angles. Alright, so those are our examples, and so your assignment is going to kind of play around with all of these types of angles. So go for it.